Okay, the next characteristic is called radiation resistance and antenna's efficiency. So antenna's efficiency in terms of power is equals to radiated power divided by the input power times 100%. Pag in terms of radiation resistance naman, radiation resistance divided by the sum of the radiation resistance plus the loss resistance times 100%. Okay, so let's solve a simple problem. So calculate the efficiency of a dipole antenna that has a radiation resistance of 67 ohm and a loss resistance of 5 ohm measured at the feed point. So may sagot na dito, no? Palabasin na lang natin using the formula. So antenna's efficiency is equals to radiation resistance divided by the sum of the radiation resistance plus the loss resistance times 100%. Okay, so 67 divided by 67 ohm plus 5 ohm times 100 is equals to 67 divided by 67 plus 5. So 0.930555 or 93.06%. Okay? So madali lang. Okay, the next characteristic is called the beam width. And the beam width is the angle between the half power point or 3 decibel region of the radiation pattern. So as we can see, we have the radiation pattern of a specific antenna. No? So we have the major lobe and the minor lobe. No? Actually, meron pa siyang side lobes and back lobes. No? Pero hindi na siya, pero negligible na kasi masyadong maliit na or mahina na yung signal strength. Okay? So, si major lobe, ito yung area ng radiation pattern when malakas yung reception dyan. So, ibig sabihin, pag nilagay mo yung receiving antenna dyan, okay, malakas yung masasagap mong signal. Okay? So, in contrary with minor lobe, pag dito mo naman nilagay yung receiving antenna, mahina lang yung reception. Okay? So, bakit ba tinatawag na half power point si 3 decibel region? I'm sure most of you na-encounter na to sa filter, no? Or sa low pass, sa high pass, or sa band pass filter. Bakit pa pag nagde-design tayo sa 3 decibel point, bakit ang makukuhan lang natin na power doon is kalahati lang ng input power? Okay, pakita ko sa inyo. So, derive ko yung expression or equation para mag-come up tayo doon sa 3 decibel point. So, halimbawa, meron tayong system. So, we have a system. And may pumasok na input power dyan. No? And paglabas, yung output power is half nung pumasok. Okay, so pag kinuha natin yung gain nitong system na to, or yung power gain nitong system, is 10 log ng P out over P in. So, lagay ko sa baba. So, 10 log output power is 1/2 ng input power divided by input power. So, cancel si input power. So, 10 log ng 1/2 is approximately equals to negative 3.01 decibel. Yun. Yun yung reason kung bakit siya tinawag na half power. Kasi pag dinesign natin ng system at negative 3 decibel, yung half or yung output power is makukuha lang natin is kalahati lang nung pumasok. Okay, so ganun lang yung essence or concept behind the half power region. Okay? So next is the effective isotropic radiated power. So EIRP is an equivalent power that an isotropic antenna would have to radiate in order to achieve the same amount of power density of another antenna. So, it is just simply the product of the transmitter power times the gain of the transmitting antenna. Okay? For the captured area, so A sub C is equals to the gain of the antenna or the power gain of the antenna times lambda squared. Yung lambda natin is the wavelength, so speed of light divided by the operating frequency divided by 4 pi. Okay? So, for the captured power or the power received, so PR is equals to power density times the captured area. Or in terms of gain naman ng transmitting and receiving antenna, so transmitter power, PT, times the receiving power, or sorry, the gain of the antenna, or the transmitting antenna times the gain of the receiving antenna times lambda over 4 pi squared. Okay, calculate the captured power 10 km away from the half-wave dipole transmitter with 10 watts of transmit power for the following antenna at 150 MHz operating frequency. So, letter A, yung receiving antenna natin is Hertzian dipole, and letter B is half-wave dipole. So, drawing natin para mas maintindihan natin. So, meron tayong transmitting antenna na half-wave dipole. So, this is a dipole. So, may size siya na lambda over 2 and meron transmit power na 10 watts. Okay, so yung receiving antenna natin is letter A is Hertzian dipole. So, mas maliit. So, less than lambda yung size. Okay, so 10 km away. Yung distance nilang dalawa. And ang tinatanong is the captured power o yung PR. So, PR is equals to transmit power, transmitting antenna gain, receiving antenna gain, and lambda over 4 pi squared. So, 10 watts. So, yung gain ng transmitting antenna natin is 1.64, no? Kasi half-wave dipole. 1.64. And yung gain naman ng Hertzian dipole is 1.5. 1.64, 1.5 times lambda is equals to C over F, no? Speed of light divided by the frequency. So, 3 times 10 to the positive 8 divided by 150 megahertz. So, dito ko na i-times yung 4 pi sa baba. Okay, squared. So, equals to 3 times 10 to the positive 8, 150 squared, 1.5, 1.64 times 10 watts, 0.623. Watts. Okay. Okay, so for discard ulit natin. I-erase natin para makapagsulat tayo doon sa susunod. So for half-wave dipole, so parehas half-wave dipole yung transmitter and receiver antenna natin. So 10 km, may transmit power na 10 watts, merong gain na 1.64 parehas. Okay, so yeah, power received is equals to 10 watts, 1.64, 1.5, speed of light raised to 8, frequency raised to 6, 4 pi squared. So equals to or 1.64 pala to, no? Sorry. This is 1.64 times 1.64 times 10, 0.68 watts. Okay, so double check ko lang ulit. 4 pi 150 squared 0.68. Kita na. So, madali lang, no? Okay. Next is the front-to-back ratio. So, front-to-back ratio of an antenna is the ratio of the energy radiated in the principal direction or doon sa main lobe or sa major lobe compared with the energy radiated in the back direction of the radiation pattern of antenna or doon sa back lobe. Okay, so ibig sabihin lang front to back is the ratio of the power na ini-emit papunta doon sa major lobe direction divided by the back lobe power. Okay? So the electric field strength in volts per meter is isulat ko medyo malabo kasi yung nalagay ko dito, no? So epsilon yung Greek letter na nandito, no? So, electric field is equals to the square root of 30 times the power transmit divided by the distance or R. Okay? So, yung distance is the distance between the transmitting and the receiving antenna. Okay? So, yung power transmit is equals to the input power times the gain of the transmitting antenna.